right, guys, last thing to add. And I don't know that this is super necessary, but just as a little bit of a tying it all together and reminding you of all the things, we're going to do one last tables and graphs examples, and that's going to be on page 50. And really functions. Okay, so if we jump ahead to page 50, we really just have this little guy right here. And I don't know that we're going to do all of them, but we'll do some of them. And so basically what we have here is that we are going to be graphing functions using an input and output table. Now, you'll find out probably pretty quickly that I do not like graphing with tables, but for now, that's kind of all we have. So if I have my function here, I get to choose whatever I want my input values to be. My independent variable or my domain can be whatever I want it to be. So I typically like to pick a couple of negatives, 0, and a couple of positives. So for this one, I'll just go -2, -1, 0, 1, 2. We don't need to do all those. Like the last 3, we don't need to. And so then, once I've picked my input values, I put each one into my function in place of x. So for this function, I'll have -3 times -2 plus 1. So we got to multiply first. So -3 times -2 will be 6, plus 1 is 7. Then we'll do it again, but now I'm going to put -1 in place of x. And so -3 times -1 is 3. Plus 1 is 4. Then I'm going to plug in 0. And see, maybe you can tell already why I don't like tables. This is very time consuming. -3 times 0 is 0. Plus 1 is 1. But if you start to notice a pattern happening with your y values, you can maybe continue that pattern out. I'm going to do another just to be safe though. So -3 times 1 now plus 1. -3 times 1 is -3, plus 1 is -2. So I don't know if you see, but we are going down 3, down 3, down 3. So down another 3 would be -5. And if I were to plug that in, you would get that because -3 times 2 is -6, plus 1 is -5. So if you notice the pattern, you can just follow the pattern out because it'll get you the right answer anyways. And I should be going down by 3 because that's what you're multiplying by. It's like the linear stuff. Anyways, okay, sorry, nerding out. So now I want to go plot these points, and we go along our x-axis first to -2, and then I'm going to go up to 7, which isn't going to quite fit, but that's all right. So 1, 2, 3, 4, 5, 6. It would be like way up there. Then I would do -1, 4, 1, 2, 3, 4. Then I go 0, 1, 1, -2, and 2, -5. Now I notice that this is making a straight line. So that boy is linear. And I can see it in my graph, but I could also tell from the table because it was going down 3, down 3, down 3. I can also tell from the equation because it doesn't have an exponent. So that is linear. Okay. Let's see. Let's jump ahead. Let's not do that one. Let's jump ahead to this one here. So this one, we're going to pick our x values. You can pick whatever you want for your input values. I like to pick some negatives, 0, some positives. So I'm going to go with -2 again. -1, 0, 1, and 2. It's just kind of my go-to. And then we need to plug each of these into our function. So we're going to have -2 squared. So like that negative is kind of like a -1 sitting out front. And then we got plus 5. So I got to do my exponent first. So -2 squared is 4. But then there's a negative outside. So this is really -4 plus 5, which is 1. When I plug in the -1 for my next input, we're going to have -1 squared plus 5. So -1 squared is 1. but then there's a negative outside, so -1 plus 5 is 4. And you really can't tell a pattern until you have at least like 3 numbers to go off of. Like it looks like maybe I'm adding 3, but I'm not. And so then when I plug in 0, 0 squared is 0, and I can't have -0. Plus 5 is 5, because see, that didn't go up by 3. Then we'll plug in 1. So I'm going to write over here just because I'm kind of running out of room. 1 squared is 1, but there's a negative, so -1 plus 5 is 4. Oh, look at that. Then I plug in 2. 2 squared is 4. With a negative out front, it's going to be -4 plus 5, which is 1. Look at that, cute. That's kind of doing a thing. All right, let's graph those points. So -2, comma 1, -1, comma 4, 1, 2, 3, 4. 0, comma 5, 1, 2, 3, 4, 5. 1, comma 4, and then 2, comma 1. Ah, so this isn't making a line, but it's kind of like going up and then coming back down. And it would continue forever because like I could have picked other x values. So like this would have continued going down that way, and this would have continued going down that way. But it's not linear. Yeah, let's do the one below it. Okay, so again, I'm going to pick some negatives. No, let's not do this one. Not yet. We're going to get there eventually. Let's do that one. We will do this one, and then that'll be it. So I'm going to pick some negatives, so 0, and then some positives. So just my old go-to. Now, these bars we talked about briefly before. Those are absolute value bars, and they're kind of like parentheses where I should do what's inside them first, and then I make them positive. So if I plug in -2, I'm going to do -2 minus 4, which is -6, but the absolute value of that is 6, and then I'm going to subtract 2 for 4. If I plug in the -1, sorry, I need more space, -1 minus 4, then -2. So we're going to do what's inside the bars first. So -1 minus 4 is -5. Absolute value of that is 5 minus 2 is 3. Interesting. When I plug in 0, we're going to have 0 minus 4, which is -4. But absolute value of that is 4 minus 2 is 2. Now, when I plug in the 1, we're going to have 1 minus 4, which is -3. Absolute value is 3 minus 2 is 1. When I plug in the 2, 2 minus 4 is -2. Absolute value of that is 2. Minus 2 is 0. So this does look like it's kind of doing a thing. If I go to -2, comma 4, 1, 2, 3, 4. Plot that point. -1, comma 3, 1, 2, 3. 0, comma 2, 1, comma 1, 2, comma 0. It seems like this is linear, but it's kind of not. This graph does something really interesting eventually, and it pops back up and makes like a V shape. So this really is nonlinear. We just can't see it yet, which is so sneaky and tricky. I promise I won't trick you like that. But eventually this graph will turn around. So like it's going to go down like this, but then it's going to pop back up like that. So we will learn about those soon, but not yet. So I just wanted to make sure that we kind of tied it all together. So when I had function notation back towards the beginning of this chapter, we talked about how we could plug stuff in and get our output value. Then I can take that input output and plot it as a point, and I can get a cute little graph and see if it is linear or nonlinear, which just really all ties the room together, and we can take this test and hopefully do well. Okay, see you later.